Bismillahirrahmanirrahim. Assalamu alaikum. I am a student of University Campus Larkana. Myself, Tanveer Gaad, roll number 2K17 LCS 43, Department Computer Science. Today I am presenting the presentation on subject compiler construction to my teacher, Madam Kuratulain Gopa. Course outline: Introduction to compiler construction, types of bugs, type checking, programming language, translator. Compiler construction. A compiler implements are a formal transformation for a high-level source program, a low-level target program. Compiler design can define an end-to-end solution or tackle a defined subset. Data interface with other compilation tools. Example: processors, assembles, links, design requirements include reco- rigorously defined interfaces both internally between compiler components and externally between supporting tool sets. In the early days, the approach taken to compiler design was directly affected by the compilability of the computer language to process. The experience of the persons designing it and the resource limitation lead to the need to pass through the source code more than once. A compiler for a relatively simple language written by one person might be single monolithic piece of software. However, as the source language grows in complexity, the design may be split into number of inter- interdependent phases. Separate phases provide design improvements that focus development on the function in the compilation process. Types of bugs, er- or we can say errors. The programmer should know that the fact that there is very less chances that a program will run perfectly in first time. It doesn't matter how nicely the designing is done and how care is taken while coding. One can't say that the program would 100% error free. So the programmer has to make efforts to detect and rectify any kind of errors that are present in the program. But before detecting and removing errors is much more necessary. The programmer the programmer should know about types of errors in programming. Types of errors in programming. Types of errors are classified into four categories. There are there are syntax errors, logical errors, runtime errors, latent errors. Runtime errors. Runtime errors are the errors that occur during the execution of the program. Some examples are dividing by zero error, insufficient memory for dynamic memory, allocation, refrigeration, and out of range array element. These are not detected by compiler while compilation process. A program with these kind of errors will not will run but produce in will produce erroneous result or may cause termination of program. Detection and removal of a runtime error is a difficult task. Syntax errors. Any violation of rules and poor understanding of the programming language results in syntax errors. The compiler can detect such errors if syntax errors are present in the program. Then the compilation of the program fails and is terminated after showing the first of errors in the line number where the error have occurred. In some cases, the line number may not exactly indicate the correct place of the errors. In, in some other cases, a single syntax error can result in a long list of errors. Correction of one or two errors in the program may remove the entire list errors. Type checking. The checking and type conversion. Type checking means checking that each operation should receive proper number of arguments and of proper data, like a is equal to b star j plus d slash and minus are basically integer and float data types based operation, and if any variable in this a is equal to b star j plus d alias of other than int and float, then compiler will generate type error. Type A type is set of value together with a set of operation that can be performed on them. The purpose of type checking is to verify that operation performed on value are in in fact perni- in fact permissible. The type of identifier is typically available from declaration, but we may have to keep track of the type intermediate expressions. Two ways of checking: dynamic type checking. Number two, static type checking. Dynamic type checking. It is done at a runtime. It uses concept of type tag, which is stored in each data object that indicates the data types of the object. Example: an integer data object contains its type and values attribute, so operation only be performed after type checking sequence in which type tag of each argument is checked. If the type are not correct, then error will be generated. Perl and prologue follow basically dynamically type checking because data type of variable a plus b in this case may be changed during program execution, so date type checking must be done at runtime. Static type checking. Static type checking is done at complete time. Information needed at compile time is provided by declaration by language structures. The information required includes: number 1, for each operation, the number order and data type of its arguments. Number 2, for each variables, name and data type of data object is the example a plus b. In this type, a and b variables must not be changed. Number 3, for each constant, name and data type and value. Constant integer x is equal to 28. Constant float x is equal to 2.087. In this data type, the value and name is specified and if further if checked value assigned should match its data type. Logical errors. As the name itself implies, these errors are related to the logic of the program. Logical errors are also not detected by compiler and cause incorrect results. The errors, these errors occur due to incorrect translation of algorithm into the program, poor understanding of the problem, and a lack of clarity of hierarchy of operations. Consider following C statement. If A is equal B, print equal N. When A and B are float types values, they rarely become equal due to duration errors. The print call may be not executed at all. A statement like while a slash is equal to b bracket over might create an infinite loop. Latent errors. Latent errors are the hidden errors that accurately occur only when a particular set of data is showed. Consider below example result is equal to a plus b c minus d. An error occurs only when c and d are equal because date will make a reminder 0 bracket small bracket divide by 0 error small bracket over. Such errors can be detected only by using all possible combinations of data. Programming language translators. A translator is a programming language processor that converts a computer program from one language to another. It takes program written in source code and converts it into machine code. It discards and identifies the error during translation. Purpose of translator. It translates a high-level language program into a machine language program that the central processing unit CPU can understand. It also detects errors in the program. Types of translators. There are three different types of translator as follows: compiler, interpreter, assembler. Compiler. A compiler is translator used to convert high level program language to low programming language. It converts the whole program in one season session and reports errors detected after the conversion. Compiler takes time to do this work as a translate high level code to lower level code all at once and then saves it to memory. A compiler is processor dependent and platform dependent, but it has been addressed by a special compiler, a cross compiler, and a source to source compiler. Before choosing a compiler, user has to identify first instruction set architecture ISA. The operation system OS is the programming language that will be used to ensure that it will be compatible. Interpreter. Just like a computer, is a translator used to convert high level program language to low level program language. It converts the program one at a time and reports errors detected at once. While doing the conversion this is easier to detect errors than in a compiler. An interpreter is detect errors than a compiler faster than a compiler is immediately executes the code upon accordingly the code. It is often used as a debugging tool for software development as it can execute a single line of code at a time. An interpreter is also more portable than a compiler as it is not processor dependent. You can work between hardware architectures. Assembler. An assembler is a translator used to translate assembly language to machine language. It is like to compiler for the assembly language, but interactive like an interpreter assembly language is difficult to understand as it is low level language. An assembler translates a low level language in assembly language to an even lower level language, which is the machine code. The machine code can be directly understood by the CPU. Thank you so much.